Landis. He's a NASA scientist at NASA Glenn Research Center and also a sci-fi author, and he's going to give us an update on how the Rovers Spirit and Opportunity are doing. Please welcome Dr. Landis. Thank you.
So, good morning. It's actually a great thrill to be back at the Mars Society Conference. I was at the first conference and then a couple of the following conferences, and then unfortunately the conferences had been scheduled poorly and conflicted with something else I had to be at. So it's great that I get a chance to come back and talk to you. At the first Mars Society Conference, the founding conference, I didn't have any results from the Mars exploration rovers because they hadn't been launched yet. So it's good to talk about what they've been doing. I'm sure that most of you have been following the continuing saga of MER on the planet Mars, but we did pretty good. We were more than a 7-day wonder. We stayed in the public consciousness for a couple of months. But after a while, MER did fade out of the consciousness of the public. You don't really see headlines made on MER. Every now and then you get a small squib on page 23 of the newspaper that says, "Whatever happened to those Mars rovers?" But in fact, the Mars rovers are still on Mars. At least 1 out of 2 of them is still exploring Mars, and we're still learning interesting things. So I'm hoping that if I can talk fast enough, I can update you a little bit about where we've been and what we've been doing. I would like to start, that's odd, my clicker isn't clicking. Oh, well, I guess I have to use the buttons here. I would like to start by talking about the fact that MER was not the very first mission to Mars. In fact, the first mission to get close-up images of Mars was this one, Mariner 4, which was a flyby mission. And a very important flyby mission, actually. Right here from the very beginning of it, we can see an important feature about Mars, which is no canals. So in 1964, our vision of Mars changed a little bit. We had thought in the early 20th century of Mars as being sort of maybe a little bit cooler, maybe a little bit more desert-like planet than Earth. But Mariner 4 told us, oops, Mars is a very barren, desolate planet. In fact, that was a little bit misleading because Mars flew by the cratered highlands of the southern hemisphere with the Mariner mission. If we had seen other parts, we might have seen different things. Which we did in the Viking mission. Great mission, the Viking mission. Sent both a lander and an orbiter. The most significant part is the orbiter looked down on Mars and showed us images like this. And in fact, we see images like this all over parts of the planet where we see all of these features that look like carved river valleys. In fact, there's been a lot of controversy over what these are, a lot of analysis, but pretty much there's a consensus now that in fact these are ancient channels carved by water. So this tells us an interesting view of Mars. It is a very cold, very dry planet. There's no liquid water on the surface. We've been watching Mars for decades, and we've never seen liquid water on the surface, although we think we've seen places where it had been. But yet, we see these features. So it is a story now of a planet that has had global climate shift. Sometime in the past, it was a warm and wet planet, that is warm enough for water to be liquid, and it's not now. So this is the story from Viking, the story of a planet that has changed over the years. And this is the planet that we're trying to explore with MER. What happened to the water? Where did it go? Where was it? Why was it there? How has it affected the planet? Well, my involvement with Mars missions, in fact, did not come with Viking. That happened when I was in college. My involvement started with the Sojourner rover, solar-powered mission to Mars. In fact, my initial involvement with Mars was the solar panels, designing and analyzing the solar panels on MER. I had a little experiment on MER to test out the solar energy on Mars. And MER was a highly successful mission. The main purpose of Sojourner. The main purpose of the Sojourner rover, in fact, was not to do science, although it did do science. The main purpose was to verify that we could rove on Mars with a solar-powered rover. And that worked perfectly. We had a great mission. We discovered we can rove on Mars. We actually did do some pretty good science during the about slightly under 90 days of the MER mission. I keep saying MER, I mean to say Sojourner, but the 90 days of the Sojourner mission. MER, of course, also had a 90-day mission. Before I go on to MER, one more thing I'd like to do is sort of do a heroes gallery of missions to Mars. There's been a lot of missions to Mars, and in fact, at the time we launched the MER, the Mars Exploration Rovers, out of all of the missions that humans had sent to either orbit or land on the surface of Mars, 2 out of 3 of them had failed. Going to Mars is hard. Here's just some of them: the Mars Climate Orbiter, the Russian Mars 96 mission, the largest and most complicated planetary mission ever attempted, the Japanese Nozomi, the British Beagle 2, the Mars Polar Lander. Somebody had been shooting down our missions to Mars, and we weren't real happy about it. So in fact, going to Mars with the Mars Exploration Rover, we did send 2. And we sent them to opposite sides of the planet. So we figured whichever way they're aiming their anti-aircraft barrage, we're coming from both directions. We'll come around from the other side. There were 2 identical rovers. And here's a view just showing that the Mars Exploration Rovers, this one Spirit, are about twice as big as Sojourner in every dimension, about 10 times as heavy, a lot more scientific equipment. And our mission in terms of picking landing sites was to go to sites where we had evidence of water. In fact, picking a landing site is a difficult task on Mars. The scientists want landing sites that are really exciting. In fact, the very first thing the scientists said is, wow, we have all this cool instrumentation, let's go to the bottom of Valles Marineris. The mission safety engineers have some criteria for landing sites, and their criteria is it's absolutely flat, no cliffs, no rocks, no mountains, no boulders, really safe landing site. And in fact, if you think about it, given that it has a radar that's watching whether you're coming close to the surface, you know, if you were flying over a cliff on your parachute and your mission says, oh, we're about on the surface, we can open up now, and then they say, oops, we're not over the cliff, that might be a bad thing. So it's a little bit tricky to pick a landing site. We picked this crater because when you look at the crater, you see, well, that's clearly an inflow channel. This was once a crater filled up with water, filled up to the brim with water. That's a big crater, by the way. I don't know if you can read the kilometer bar, but that's 100 miles across. That's a really big crater. It was apparently a huge dry lake once. So we went there because it's a place that had signature of ancient water. Here was our first view on landing. You look at it, actually looks kind of like a desert to me. Doesn't really look like a lake bed. The geologists, however, were thrilled. They looked at this, they were jumping up and down, they were cheering. They were saying, wow, this site has everything that we need in a landing site. It's got rocks. Geologists are easy to please. It also had mountains off in the distance. I say mountains, actually they're hills, they're not terribly high. But the MER mission was designed for a lifetime of 90 Martian days, 90 sols. A solar day on Mars is a sol. And a roving distance that was considerably less than the distance to these hills that are about 2.7 kilometers away. I should talk a little bit about what the design specifications are. If you are building a mission, especially to a mission to a place where we don't have perfect knowledge of the environment, you have to have a specification. You have to tell the engineers, what are you designed to? And the engineers say, well, if you want 1,000 days on Mars, here's what it's going to cost. So there's a give and take between the scientists who say, we want to do everything, and the engineers who say it's going to cost you. So the mission is designed to worst case conditions. We were designed to say, well, what's our worst case dust? What's our worst case degradation of the motors? What's the worst case thermal cycling? And in fact, the engineers tested everything to 3 times design lifetime. So they were designed for 90 Martian days. They were tested, in fact, to 270, because the only way to know it'll last for 90 days is to test it to 3 times that long. So, among other things, it was designed for a good solar conditions. We were landing in the summer when there's lots of sunlight. They weren't really designed to operate in the winter when the sunlight goes away. But here is our view of the landers, the Pathfinder. Now I'm going backwards. The Spirit, once it's landed on Mars. And in fact, you can see the beautiful, nice, clean solar arrays. Next time we see them, they won't be so clean. Here's some of the pictures from early in the mission. So you've probably seen a lot of pictures. This particular one is approximately true color. This is about what you'd see on Mars. Mars is not the red planet. It is the butterscotch planet. It's about the color of adobe. The geologists actually know this. They know what color Mars is. They aren't interested in that color anymore. They usually show pictures like this. This is exactly the same image, but the colors have been stretched. They haven't been changed, but they've been stretched. So essentially, they turned up the knob on the blue and the knob on the green to make the brightness of red, blue, and green approximately equal. Brings out a lot of details. So when you see images of Mars that have blue rocks, you know they are stretched images, stretch color images. But in fact, this was a 13-color camera that could see into the infrared. So you can see a lot more colors than merely the true color or the stretch color. And here's just some examples of some of the color stretching that you can do on Mars. I kind of like this picture because it's Andy Warhol. I think, eat your heart out, Andy Warhol. This is art. Here's another one of these decorrelation stretches that brings out all of the subtle details in the colorations and layers of the rock. So you can see a lot of details with these cameras when you stretch the color. As I said, there were 2 Mars rovers. Second one bounced down across the planet about 3 weeks later. Just absolutely by luck, it made a hole in one in this little crater. So they named it Eagle Crater. And there it is. This is a view from orbit from the Mars Global Surveyor. You could actually see the lander. And if you looked really closely, you could see the rover in the crater. And the geologists were excited by the first landing site, but they were ecstatic about this one, because by landing in a crater, it turned out we could get the stratigraphy of the rocks, because it had blown through to bedrock, and we could see layered rocks. Here's the true color image of our landing site. Here's a false color image that brings out a little bit more of the details. What you can see is lots of sedimentary rock. This stuff was laid down at the bottom of an ocean or perhaps a very briny lake, and it's laying down these magnesium and iron sulfate salts. So this is the salt that is left behind when an ocean evaporates. And what we discovered is that there were many instances of water on this spot. Water had come in, it evaporated, laid down layers, more water came in, more evaporated. The geological story of this site could go on for a long time, but the mission went on for a long time, so I'd better move on and rather than talk too much about the Eagle Crater site. Well, those hills off in the distance, the very first thing when we landed, we said they're too far away, we can't go there. But after the mission, the 90-day mission had lasted 100 days or so, we looked at it and said, well, we're clearly outliving our warranty. Let's head for that crater and head for those hills and gun it. So we did. We headed for the hills. Here we are at Sol 500.